everyone. Today we're going to talk about axonometric drawings and Paraline drawings. And so let's get started, shall we? So we are going to talk about Paraline drawings. And that's really those drawings that make things look three-dimensional. Here's some of the vocabulary terms we may go over. The term Paraline drawing and different kinds of orientation, rectilinear, bird's eye view, worm view, isometric drawing, elevation oblique, and plan oblique. Those are drawings we're really going to focus on today. Some concepts like surface textures and different types of methods, subtractive methods, and traceable methods. Just talk a little bit about thicknesses and line weights and types again, and some of the material representations that go with this type of Paraline drawing. So before we were talking about multi-view drawings, orthographic projection we just did for interior elevations and exterior elevations, for floor plans and reflective ceiling plans, and sections. But now we're going to focus now how we take these drawings and create something that looks more three-dimensional. Now remember, all of these multi-view drawings, they are the correct scale. They're very reliable. They're the right shape and portion. And so they are something that you can actually build off of, but they don't visually look correct. So when you look at all these multi-view drawings, you're looking at a floor plan, reflective ceiling plan, and elevation, but visually you have to put them all together. And so they don't really represent what the whole structure looks like. So now we're taking it to a next level with the Paraline drawings that will sit there and put all the components together to create a clearer vision for the viewer. Now, mind you, you don't need the Paraline drawings to do architectural detailing and drawings. We do use just the multi-view drawings, but it's more for conceiving and conceptualizing the entire space. So it really helps the client to view what the space looks like and overall communicates your design intent. So with that being said, you know, these types of multi-view drawings, they require a lot of different types of emphasis on how to read them. With line weights and textures and prioritizing how to use those line weights. Well, in the next type of drawings that we're talking about, we don't rely on those as much. What we're doing is that what it says about multi-view drawings is that they alone, they don't tell the full story. You're only getting one view at a time. And these require many views to even communicate your design intent. You need a top view, you need front and side views, and you need section views. You guys have done all these drawings and that really helps communicate the building. But this next phase is going to go a little step further. And these are what we call more pictorial systems. They give a picture, they're more comprehensive, and they kind of tell you the whole story. They're like models that illustrate a different image or effect. Now, there are three different general types of pictorial categories. We have been working just in this one, which is multi-view, the top, bottom, sides. But once we get into these viewpoints, these axonometric projections and oblique projections, which we call Paraline drawings, this is when you start to see multiple views at one time. So that's kind of what this is depicting, multiple views at one time. Now, later on in your design career, you will get into perspective projecting and perspective drawings. But in this class, we are going to stick with the Paraline drawings, and you will be taking an entire course on perspectives. But let's get started to the concepts. Paraline drawings, the general conditions for a paraline. What does this mean to paraline, like, you know, a parallel line drawing? So we use this when we take a drawing and we tilt it and we move it. We tilt it and now we have created multiple views. So a paraline drawing, the general conditions. Used to illustrate 3D characteristics. It has a width, a height, and a depth This is different than our multi-plane drawings, which only have an X and Y, a width and a height. What a Paraline drawing adds is this right here. There's 3 different angles. You have your X, which is horizontal, your Y, and then you have this Z axis that gives us that corner. That's what gives us this 3-dimensional line, the fact that we have an X, a Y, and a Z axis. And we can view them at the same time. When we had multi-view drawings, we just could only see one view at a time, the horizontal and vertical view of something. But in these Paraline drawings, we see 3 different views. One way, this way, and then going up. Okay, so that X is going up, as you see. So this represents a 3-dimensional object, and it's scalable. You can actually put a scale to this. So if you go up 8 feet, that's how high the corner of this box is. You go across 8 feet, and then you go across 8 feet. You can actually put a scale to this as well. And they give you a rectangular orientation. So we're used to, it's like a rectangle. So there's a corner here. Now, we also created these axonal lines right here. And this whole entire premise is what actually dictates a Paraline drawing. We can map this out, and they have these 3 axes, X, Y, and a Z. So you'll see this when you start to do AutoCAD. You will use this when you do SketchUp, especially creating a 3-dimensional room. By basically, you're doing Paraline drawings. You're putting in a floor plan, and you're elevating, and you're extending all of the walls straight up in that X, Y, and Z, the Z axis. That's what brings the walls up. You're no longer dealing with a flat 2-dimensional plane. So these Paraline drawings are very beneficial to helping us see the whole picture. So remember that they have an X and a Y and a Z axis. And the Z axis will always be going straight up, creating this elongation. Now, Paraline drawings, like I said, they give you a 3D illustration of a form. And the 2 we want to really focus on, because we'll be doing this in our next lesson as I do a demo, are the oblique drawings. There's 2 types of Paraline drawing types. These are called exonometric views, and there's a plan oblique and an elevation oblique, and I'll define those. But these are definitely 2, the oblique drawings are something that are very similar, and we're going to do this with the exterior of our house. You've already done the section, you've done the exterior elevations. We're going to tilt our house at a corner, and we're going to elevate the walls just like this. It's called a plan oblique. Let's get to the difference. So a plan oblique, it basically, because this is the word plan, it basically uses the floor plan. So a plan oblique, some of the characteristics, the orientation of it on a horizontal plane. So you take it on a horizontal plane, parallel to the picture plane, and then you turn to the plane. So you actually tilt it. So you take the floor plan that's normally horizontal and you flip it 45 degrees or 60 degrees and you tilt it. It is true to size, it's true to form and function, and it's actually using the floor plan as your basis for the drawing. And so it's a very steep angle when you tilt it. And the vertical lines sometimes are foreshortened so you can see inside the building, and they don't always go up the exact height. But right here, this is what we use. A plan oblique uses the actual floor plan as its basis, the entire floor plan. And that is the face. And let me show you what that looks like. So you would take the floor plan that we're using. This is the floor plan that we are using. And it was originally horizontal, and you tilt it with your 45-degree angle. In our case, we will be using a 45-degree triangle. Now, you can also tilt it using the 30-degree triangle and the 60-degree triangle. But in our case, we are going to use a 45-degree triangle. We will tilt the floor plan as you see it, just like this, and you will, on the z-axis, you will extend these lines up the height of the walls. Once you extend all of the lines, then you start to connect all the dots. So you take a floor plan, you rotate it 45 degrees using your 45-degree triangle right here, and you draw the vertical lines on an x-axis up to the correct height of the building. So as you can see, you're taking your floor plan, tilting it, and then you're taking each line and you're scaling out. If the walls are 13 feet, you're going to go up 13 feet. If the entry into the door awning is 9 feet, you're going to go up 9 feet. So you will take a scale and you know all your heights because you have your exterior elevations and it's all right there. So you go for your exterior elevations and you just project up all of those vertical lines that will extend the building from making it a flat plan. It's flat, and then you're pushing it up. And as you tilt it, you're able to see 3 different dimensions. So this is how we'll end up doing our demo, you'll see. So as you see here, that's the idea here. They tilted this, it started off horizontal, they tilted it, and they used their triangle to create this line. And then this is what we call an oblique, an axonometric, oblique drawing, plan oblique. And you will extend these lines up. And we are not going to look inside of our building, but if you were to look inside, and it's a really cool way to see what's going on inside. Often we'll kind of foreshorten the wall so you can see more of it. If they're very high walls, you can't see what's going inside. But then you actually, take every interior element and extend it up. In our case, we're going to simplify it. We're only doing the outside. But this is a really cool way to see what's going on inside your space by taking these scaled vertical lines and giving them height. Now with an elevation oblique, it's similar, but instead of using the plan view, you are using the elevation view. And once again, using orthographic projection, and instead of projecting your lines upward, you are now projecting them at that 45-degree angle. So when you're dealing with an elevation oblique, it's like my face, and then if I turn to the corner, I'm extending the line so that you see the side of my face now. So the other was a plan that was flat and you tilted it and you extended the line to push it up. The elevation, you have a face and you're pushing it back and you're extending it, creating it. So you're using the elevation as your base drawing and you're just taking these diagonal lines. You're going with the X and the Y now and you are pushing back. The other, you already have your X and Y set and you're pushing up the Z axis. So they're a little bit different, and you use your triangle and you draw the exact scale. So as you see here, you would measure this. Let's say that was 12 feet. You would take a scale, go 12 feet at your 45-degree angle, tick mark it, and then use your 45-degree and just project those lines up and then connect them. And this face is what we start with. So this is a simple object, but we will use exterior elevations. So this gives a good illustration. If we're going to use one of our exterior elevations, in this case, for an elevation oblique drawing, we would take the triangle and we would use the diagonal lines, and that would be going the X way, and then tilt the triangle and go the Y way. That's where you get your elevation oblique. You just take the elevation, you use your 45-degree triangle, and you draw the diagonal lines to elongate the drawing. And that gives you that appearance. So once again, a little recap on these oblique drawings. Now we'll get into isometric. They're similar, but right now we're speaking of the oblique drawings where you actually had a plan oblique where you took the floor plan right here. They tilted it, and then they extended the lines. Now you can tilt them different ways. The two most basic ways is using either a 60-30 triangle or a 45-degree triangle. This is why we had you buy both. The 30-60 triangle gives you two different angles, so it kind of tilts it a little off. It's not perfectly even, okay? It's kind of a little off, which is kind of cool. Sometimes you want to see it a little off because one side might be longer and you want to see that side. When you do it even, it's just all even on all sides. So in our case, we're going to use a 45-degree, perfectly even tilt. But later on in the semester, you will be using your 30-60 triangle for an isometric drawing, which we'll get into a little later. So here we have our plan view. They tilted it right here, 60 degrees. Here they tilted it 40, and here they tilted it 30. So it just kind of depends how you want to shift it. But you see here, this is exactly symmetric, meaning even. When you tilt it a little, you kind of get it a little off kilter, and sometimes we like that because it depends what face we want to show more. So if we want to show this face more and that less, we would tilt it this way. If we want to show this face and this face equal, we would tilt it perfectly equal, 45 degrees. But if we want to tilt the drawing so that this face shows more, we tilt it more that way. So just kind of it emphasizes one principal face when you do the 60-30 angle. But the 45, you emphasize both equal. Depends on what you're looking for. So Paraline Drawings, like we said, now we're going to talk. We just talked about the oblique drawings, Paraline Drawings. There's plan oblique and elevation oblique. The next type of Paraline drawings are called axonometric views. And these axonometric views, there are three different kinds. One's called isometric, dimetric, trimetric. So as you can imagine, iso, meaning like isolated, stands for one. Di means two, and tri means three. So that's a great way to memorize it. The most common Paraline drawing for an axonometric view that we use as interior designers is the isometric view. And what does that mean? That is using one angle, exact angle. That's the same. They're just equal, just an equal angle on each side. That is iso, one angle. It's three axis lines with equal angles. So the X, the Y, and the Z are all equal, just one. The dimetric view is two angles. So this is equal and that's equal, and then this is a different angle, giving us two angles. So this is completely parallel right here. There's one, and that's two. The tri is three different angles, where this is a different angle, this is a different angle, and the Z is a different angle. Those are three different angles. But the isometric is what we use mainly, where we take a triangle that's 30 degrees and we flip it one way and then we flip it the other, and it's equal on each side. This is a little different than the plan oblique. And we will go in the details in the second half of the semester. We will do an isometric drawing where I will do a demo of it so you'll get an idea. With the plan oblique, you're using the plan and you just tilt it and you just bring up the lines. So it's simple. With this isometric drawing, you need your triangle and your scale because you're not using the floor plan as your reference. You will be scaling off the elevations to create your drawing. So you will see how wide it is, and you'll scale it at that 30-degree angle. You'll see how high it is, and you'll scale it. And so it's really a different way of transferring your drawing. And the difference is a plan oblique is a floor plan, and you're really looking inside. When you start to do isometrics, they're tilted a little bit more this way, so they don't look so fully into it, like you're looking right into it from a bird's eye view. It's a little bit more tilted, and it has a more realistic view. And we will be doing a kitchen in that manner. We don't want to tilt the whole thing so forward. That's what a plan oblique does. An isometric just kind of brings it a little forward, gives it more of a realistic viewpoint. It's a little bit more time consuming, a little bit more complex. So that's why we start off with the plan oblique. You just have your floor plan. We just bring up those vertical lines and connect the dots. This is this one's ISO is scaling and ticking off and measuring. So, and it creates a little different plane and a viewpoint. So as you can see, it's different. See this like drawing than perhaps something that's very tilted. That's why this plan oblique is more tilted, where this is more subtle. Okay, it's a little more subtle. It seems a little more grounded. So remember, ISO is one angle. They're all equal angles. A diametric has two different angles, and a trimetric has 3 different angles. Now these Paraline types, and I just kind of went over them, the isometric oblique drawings. The isometric drawings, like I said, equal emphasis on the drawing face. So when we do an isometric, ISO 1, they're all the same. We will be using our 30-degree triangle on both sides. Do you see that right there? You would flip your 30-degree triangle. The first thing you would do is draw a line. Then you would flip that triangle and draw one this way. And then right here, a vertical line. This becomes your X, Y, Z axis. And your whole drawing corner sits right here. And this gives equal attention to both sides. And it just kind of is not tilted more in your face. So equal emphasis on the drawings. View angle is a little lower, like I said, than the oblique. It's a little bit more flattened down. It's not lifted and tilted up in your face more. The plan and elevation's not directly used. So before, like I said, we use the floor plan. But in the isometric, we're going to scale it, and we're going to create our lines to start with and scale out our drawing. And establishes an axis principle. So right here, between here and here is 120 degrees, but don't get confused. They're just 30 degrees here and 30 degrees there. So Paraline drawings, the isometrics and oblique drawings, be cautious because they give us an optical illusion. That's what's so cool about them, and causes them a little bit of a difficulty with interpretation. So sometimes, let's move that there. This all looks like different little, see, once you start carving all these spaces out, you can create a multi-layered viewpoint. So that's the excitement about it. This helps to interpret a difficult form. And it really does give an optical illusion of 3 dimensions. And that's kind of what we want to achieve with these. You could even get more complex using, various forms. So you have to kind of be careful when you start to connect these, because right here, they connected that plane, yet they didn't connect it here. So it's off. So there's some weird, interesting things going on. And you have to kind of be careful as to how you are interpreting these 3-dimensional objects. So similar approach for all 3. So your isometrics, your plan oblique, your axonometric drawings, and your elevation obliques, they're similar in the understanding. The whole idea is to create a 3-dimensional object by using an x-axis, a y-axis, and that z-axis, which is up and down. And by doing that, we create this look. Here we want to take just a little look on the subtractive, how you can kind of what we call carving out, or the subtractive a method where you start off, it's kind of like blocking out drawings. You start off with a simple box, and then you go and you start to find out where there's different components inside that floor plan. So you start to tick off, let's say there's another wall here at 4 feet, you go up 4 feet, maybe go over 6 and back over 4, and then you start bringing up those lines. So you start carving out that space. Then you get more into the complex shape. You realize that that little area has a little roof on it. So one side of the wall is one height, the other. So it is a process of carving things out. And I know that you do that when you are blocking out drawings. But this gives us a chance to be able to lift up various components in the space and then start to connect them and carve out. But you always start off with a simple block, and you work your way into more detailed information. So So this helps us to reveal what the really final form will look like. So once you start to do this, there's also the other way where you actually start with the form and start adding forms on. And it's a second way to kind of work and do a complex isometric or oblique drawing where we add shapes to it. So you might start off with a rectangular box and then know that there's a protruding element. So you start to add those protruding elements on the surface. And that's another way to work on some of these drawings. So don't get too hung up on, as I show the demo, you'll kind of see how we can project these lines up and start carving out the space. Our exterior building is, has protruding windows and so forth. So you start to see it come alive, but we start off with our rectangle and then we start to, in this case, more add on to the outside of the rectangle, these complex shapes. In an interior, we tend to do the opposite where we start off and then we kind of carve our way in. So it just depends on what you're trying to draft. Now, there's also ways to even create circles that look like they're in the correct proportion. And how we do that is similar. And, I'll show these more in demos, but straight on, it's easy to see a circle. But how do you make it look realistic when it's at an angle? So if you connected these and we put a triangle here and we made them right at the correct angles and we connected where these met and you brought that same angle this way, you start to connect the dots and you're almost creating an oval shape. This will make it more realistic. Like you've tilted it now. It would look different. A circle straight on looks like a circle, but once you tilt it, it starts to look like an oval, right? It's a little elongated. So there's also methods to do that. We don't get too much into circles in this particular drawing we're doing, but there is a way to make it look realistic. And it's really the same principle, just connecting the dots and creating more of an oval type shape. When you start to bend things, they change in depth. So circles are done in that fashion. So if I actually connected them together, you'll see that these line up, this and that line and that line. So once you have it there, you just continue your diagonal lines and you connect them here, and then you create this oval type shape. So as we kind of continue to kind of wrap up through this element, Paraline circles, like I said, they appear like ellipses. So that really helps us. And we use these projected angles and the base angles and extend them along that angle and connect the dots where they meet, and it really creates an ellipse. We also use templates and so forth. And this is in the textbooks. You might want to look at this and further read on it, but we really won't be actually quite doing that right now. So just to kind of close out, as I said, we have this whole series of multi-view drawings, and they all line up and they actually just stack on top of each other, creating a beautiful three-dimensional Paraline drawing. So if you use a plan oblique, here's your plan. You start to bring up those walls, maybe the first floor, second floor, and then you start to create the roof, and see how it's just kind of broken down here. So you can use plan obliques and isometrics to really analyze an interior space. In some cases, we will be going more into it with the kitchen in the second half of the semester with our isometric drawing. So you're going to see how it looks and how high the cabinets are, and it's like we're taking a little snapshot of the interior. On our a plan oblique drawing, we're just going to be doing an overall exterior, and we're going to see the whole form come to life. And that will complete all of our multi-view drawings. So this is exciting that we're finally kind of wrapping up on this three-dimensional viewpoint of this project, this home that we've been working on. So you kind of really get the whole picture. So hope you enjoyed the lecture, and I will see you at the demo.